All right, this is part 2 of the review for the final exam for Calculus 1. And I believe I missed number 1 of the problems here. This should be problem number 17 when we were doing the related rates on the previous video that I recorded. Okay, so that's problem 17. This is problem number 18. Find the critical points of the following function f of x is equal to 3x squared plus 5x plus 1. All right. Now, anytime you're finding critical points, you want to find the first derivative of that function and then set that first derivative to be equal to 0 and solve for x. And that will give you your actual critical number, I should say. As in the answer, it's going to say the critical points occur at x is equal to what? So let's find the derivative of f of x is equal to 3x squared plus 5x plus 1. So if I take f prime of x, the derivative of that 3x squared plus 5x plus 1 would be, take the 2 multiplied by 3 will be 6, copy the x to the 1 less power, plus the derivative of 5x will be 5. So f prime of x will be 6x plus 5. And then we set f prime of x to be equal to 0. So f prime of x was 6x plus 5. We'll set that equal to 0 and solve for x. So if I move the 5 over to where the 0 is, that'd be 6x is equal to negative 5. That's the same as subtracting 5 on both sides. Divide both sides by 6. X will be equal to negative 5, 6. So this is what we call our critical number. In this case, the critical point occurs at x is equal to negative 5, 6. And that's all there is to it, because that's all they're asking for. Take the first derivative, set it equal to 0, solve for x. For your critical, for the x value of your critical point. Problem number 19 is this. Find the intervals on which f is increasing and the intervals on which it is decreasing. And in this case, we got f of x is equal to 3 plus 5x minus 3x squared. Okay, so I'm going to do this at the bottom of the page. So here's the function f of x is equal to 3 plus 5x minus 3x squared. First, we find the first derivative of this function. All right, so the derivative of the derivative of 3 plus 5x minus 3x squared. The derivative of 3 is 0. The derivative of 5x will be 5 minus the derivative of 3x squared will be 6x. So f prime of x will be 5 minus 6x. Now let's set f prime of x to be equal to 0. That would mean that 5 minus 6x, which is what f prime of x is, would be equal to 0. Let's see. If I move the 6x over to where that 0 is, I'm going to have 5 is equal to 6x. Divide both sides by 6. That means x is equal to 5, 6. This represents a critical number, or the critical point where, or that would be the value where the critical point occurs, I should say. Now I'm going to draw a table. So my critical number is at 5, 6. So that means my intervals on this number line will be from negative infinity up to that critical number, 5, 6. And then from 5, 6 on to infinity. This will help me determine the intervals where the graph of that function will be increasing and where it is decreasing. And then I pick a test point. For negative infinity to 5, 6, I picked 0. because I know 0 is less than 5, 6, and that's an easy number to work with. So I'm going to substitute the x in f prime of x with 0. So I'm using f prime of x, so I'm just going to substitute that x with 0. So this will be f prime of 0. If I substitute 0 in for x, I'm going to get 5 minus 0, which is 0. Excuse me. Okay. And I can do this. I'll write it out on paper. 6 times 0 is 0. 0 from 5 will be 5, but it is going to be positive. So that tells me from negative infinity up to 5, 6, this graph will be increasing. The graph, the function will be increasing. And then from 5, 6 on to infinity, let's use 1 as a test point. And then evaluate f prime at 1. This will be 5 minus 6 times 1 ends up being negative 1. So here is negative, so that means from 5, 6 on to infinity, the graph of the function will be decreasing. So this will tell me the intervals where this function will be increasing and decreasing. Here is increasing from negative infinity to 5, 6. So we're going to choose this choice, negative infinity to 5, 6, and decreasing on the open interval from 5, 6 to infinity. And they tell you open interval, so that means you have to use parentheses. No brackets here, just parentheses. Okay. So that's how we complete problem number 19. All right, now problem number 20. Determine the intervals on which the following function is concave up or concave down. Identify any inflection points. And here in this case, we got f of x equal to 2x to the 4th minus 2x cubed plus 9. All right. So if we're finding out the intervals on which the function will be concave up and concave down, we have to take the second derivative. So I'm going to do this at the bottom of this page. So here f of x is equal to 2x to the 4th minus 2x cubed plus 9. I need the first derivative, and then I can take the second derivative. Let's start with the first derivative, f prime of x. The derivative of 2x to the 4th, that will be 8x cubed, minus the derivative of 2x cubed will be 6x squared. The derivative of plus 9 will be 0. Now that first derivative will only tell me the intervals where the graph is increasing and decreasing. But for concavity, I need the second derivative. So this is f double prime of x. Let's take the derivative of the first derivative. The derivative of 8x cubed will be 24x squared minus the derivative of 6x squared. That's 12x. All right, so now let's find our possible points of inflection by setting f double prime of x to be equal to 0. Okay, so in this case here, we're going to set f double prime of x to be equal to 0. That means 24x squared minus 12x. That's going to be equal to 0. Now let's factor out the 12x. Because 24 and 12 have a factor of 12, x squared and x has a factor of x. And if I do that, I'm going to have 2x here minus 1 equal to 0. And then we set each factor to be equal to 0 here. So I'm going to set 12x to be equal to 0 and 2x minus 1 to be equal to 0. Now for 12x equal to 0, that means x has to be equal to 0. But 2x minus 1 is equal to 0. That means 2x must be equal to 1. Divide both sides by 2, you'll get x is equal to 1/2. These are my two possible points of inflection, x equals 0 and x equal 1/2. For the possible x values where I do have points of inflection. All right, so let's draw a number line to determine whether it's going to be concave up or concave down. I'm going to put 0 here and 1/2 here. Since we're dealing with the entire number line, there are no restricted interval that they give me. So this first interval will be from -infinity up to 0. The second one will be from 0 to 1/2. And the third one will be from 1/2 on to infinity. So for -infinity up to 0, let's use -1 as a test point, and then replace each x in f double prime of x with -1. Well, by looking at this, let's see here. If I square the -1, that's going to be 1 times 24 will be 24. Minus 12 times -1 will be a plus 12. 24 plus 12 will be 36. That's going to end up being positive. So if it's positive, that means on this interval from -infinity to 0, the graph of the function will be concave up. And then for 0 to 1/2, we're going to have to use 1/4. And then do f double prime 1/4. And this is where I'm going to have to use the calculator to do this one, since we're dealing with a fraction here. And I'm using 1/4 as a test point. So in f double prime of x, so this will be 24, and then 1 divided by 4, close parentheses, square it, minus 12 times 1 divided by 4. Here I get a negative value, -1.5, but it's going to be negative between 0 and 1/2. That tells me that the graph of that function on that interval 0 to 1/2, it will be concave down. And then from 1/2 to infinity, I'll use 1 and then substitute the x with in f double prime of x with 1. Well, that's going to be 24 minus 12 will be 12, and that's going to be positive. So the graph on the interval 1/2 to infinity will be concave up. So we can see here, we're going to have a change. We do have a change in concavity. So that means we're going to have inflection points here. So let's answer those questions up here. And we're going to have to select the ones here that best fits this graph. All right, as you can see that the function is going to be concave up on two intervals, from -infinity to 0 and from 1/2 to infinity. Okay. I don't think I have enough room on this here, so I'll just mention it down here. It's concave up on these intervals, -infinity to 0 and from 1/2 to infinity. And from 0 to 1/2 is concave down. Okay. So I have to indicate that down here because I don't have any room for the space for the type to write in my answer. Now let's locate any inflection points of that. Okay. And we do have a point of, well, we do have inflection points that occur because we have a change in concavity. We're going from concave up to concave down at 0. And then we're going from concave down to concave up at 1/2. So for 0 and 1/2, those are your two inflection points. Well, you have two inflection points. One occurs at x equals 0. The other one occurs at x is equal to 1/2. Okay. Now, problem number 21. Then we're going to perform a first derivative test on the function f of x is equal to 2x cubed plus 3x squared minus 36x plus 4. And we're given the interval from -3 to 6. So in this case here, we're going to locate the critical points of the given function. All right, so let's start by, here's our function f of x is equal to 2x cubed plus 3x squared minus 36x plus 4. And this is our closed interval, -3 to 6. So we can see that it is continuous on that closed interval, -3 to 6. Let's take the derivative of this. F prime of x will be, in this case, the derivative of 2x cubed, that's 6x squared, plus the derivative of 3x squared will be 6x, minus the derivative of 36x will be 36. The derivative of a constant is 0, so that's what f prime of x is. This is differentiable on the open interval, -3 to 6. Now let's set f prime of x to be equal to 0. So we're setting 6x squared plus 6x minus 36 to be equal to 0. And then we're going to solve for x here. Let's factor out the 6 first. If I do that, I'll have x squared plus x minus 6. And I can factor x squared plus x minus 6 into 2 binomials here. X squared breaks up as x and x. The factors of 6 that give me the middle term of x will be a plus 3 and minus 2. So I get 6 times x plus 3 times x minus 2 is equal to 0. Setting each factor equal to 0, this will be 6 is equal to 0, which I can eliminate because that's a false statement. And then x plus 3 is equal to 0. X minus 2 is equal to 0. Well, for x plus 3 is equal to 0, that means x is equal to -3. And for x minus 2 is equal to 0, x is equal to 2. However, I need to eliminate any x values that are not in this open interval, -3 to 6. -3 is not in this open interval, so that means I need to get rid of that. So here, x equals 2 would be a critical number. That's my only critical number. I have to eliminate x equal -3 because it's not a part of the open interval. So x equals 2 is the only critical number that's in that interval, -3 to 6. All right, but I am going to use that x equal -3 to determine whether I have a local maximum or a local minimum, okay? Because that's going to be part B. Locate the local maximum and minimum values. All right, so I'm going to do part B over here. Okay, I am going to use the -3, and I am going to use the 2. So I have 3 different intervals. And actually, notice here, from -3 to 6. Okay. So this interval will be from -3 up to 2, and then from 2 to 6. Okay. So I really don't need this part right here. Because I need to only just focus from -3 to 6, and -3 will not be included. So from -3 to 2 will be one interval, and then from 2 to 6 will be the other interval. All right, between -3 and 2, let's use 0. And then we're going to evaluate f prime of 0 using this f prime of x function. This will be 0, this will be 0, minus 36 will be -36. So that means that's negative. So that means that the graph of this function would be decreasing. And then from 2 to 6, I use 3. So I'm going to evaluate f prime of 3. Substitute it in the f prime function. This will be 6 times 3, and that's squared, actually squared. Plus 6 times 3 minus 36. All right. That's going to give me 36, which is positive. So that means from 2 to 6, the graph of that function will be increasing. All right. So the only thing I have here, since it's decreasing and then turn around increasing, I only have a local minimum because it's decreasing at all the way to 2, and then at 2 is after 2 it starts increasing. So that means I have a local minimum at 2. So if you were to choose that, let's see, there are local minimums at x is equal to 2. There are no local maximums. And I might as well put up here for part A that the critical points are located at x is equal to 2. So there's only a local minimum. And for local maximum, we can just say none. So that right there is part B. All right, part C is to identify the absolute maximum and minimum values of the function. All right, so we have to use the original function f of x is equal to 2x cubed plus 3x squared minus 36x plus 4 to identify the absolute maximum and absolute minimum. So I need to evaluate f of -3 and f of 6. Those are my endpoints, -3 to 6. I need to evaluate what f of -3 is and f of 6 is. And I also need to evaluate f of 2, which is my local minimum. Okay. Now, the way you can do that is go to your calculator, go to y equal to, I'm going to clear all these equations out here that I've used previously, and then you can type in what f of x is in the calculator. I'm going to show you how to do that. Here you got 2 xc theta for the x, the hat key, and then 3. Right arrow to get out of it, plus 3 xc theta for the x, and then x squared minus 36, get the x, plus 4. And then you're going to go to second and table set. You want to make sure that for independent, you have ask highlighted. If it's not, you need to use your down arrow key, put the cursor on top of the word ask under independent, and then press enter. And then I'm going to go to my table and do second graph of the table. And I'm not sure if I'm able to do this. I tried to do this myself, but it's not helping. Yeah, now it is. Okay. And now we're going to enter each of these X values individually, like -3, type in -3 and then hit enter. It will give you the value of this function when X is equal to -3. And in this case, it came out to be 85. And then for 6, you get 328. And then for 2, we get -40. Okay. So the absolute maximum, and they just want the value, the absolute maximum value. So the absolute maximum, that's the largest of these three, which is of course 328. And then the absolute minimum, that's the smallest of these three, in this case, -40. All right. So to answer that question in part C, the absolute maximum is 328 and the absolute minimum is -40. So this one. Okay. Absolute maximum value 328, absolute minimum value -40. Okay. So that's how we do problem number 21, A, B, and C. All right, problem number 22. Here we're going to use linear approximation to estimate the following quantity. And we're going to choose the value of A to produce a small error. In this case here, we got the square root of 85. Using linear approximation. All right, that would mean here that X is equal to 85. So that means we need to choose some value of A that is a perfect square that's closest to 85. Okay. Now, the perfect square that's close to 85 would have to be 81, because I know 81 is a perfect square. Now, if you want to, you can write out all your perfect squares. You'll see that 81 is close to 85. So we use that. All right. Now, the function that we're going to have to use, f of x is equal to, since we're dealing with the square root, the square root of x. And also, let's take its derivative of the square root of x. If you recall, it's going to be 1/2 square root of x. Okay, the derivative of the square root of x will be 1/2 square root of x. All right, since f of x is equal to the square root of x, that means f of a will be equal to the square root of a, and I'm letting a be 81, so the square root of 81 will be equal to 9. And then f prime of a will be 1/2 square root of a, and a again is going to be 81, so I have 1/2 square root of 81. Square root of 81 is 9. And then the denominator, 2 times 9 would be 18. So f prime of a would be 1/18 when I let a equal 81. Now I'm going to use that linear approximation formula. If you recall, that will be L of x is equal to f of a plus f prime of a times the quantity x minus a. This is what we call our linear approximation formula. And in this case, x is going to be 85. So the linear approximation for 85 would be this. F of a was 9 plus f prime of a, that's 1/18, times the quantity x minus a. Here x is 85. minus the A, which is 81. Now, if we simplify this, this will be 9 plus 1/18 times 81 from 85 will be 4. And I'll do this in the calculator because they want the approximate value here. Let me check here how they want this to 3 decimal places as needed. So in this case here, if I type this in, this will be 9 plus, let's see, 9 plus, and in parentheses, I'm going to do 1 divided by 18, close parentheses, times 4. So to 3 decimal places, this will be 9.222. Now that represents a linear approximation for x equal to 85. And of course, let's see how close we are if we take the actual square root of 85. A little bit more than the actual square root, but it's close to it, as you can see. All right, so that's problem number 22. Excuse me. All right, problem number 23 deals with differentials. Consider the following function and express the relationship between a small change in x and the corresponding change in y in the form dy is equal to f prime of x. And in this case, we had f of x is equal to e to the 6x. Well, in this case here, let's take f prime of x. Well, the derivative of e to the 6x, that's the easiest derivative to take, which is going to be e to the 6x. However, we need to apply the chain rule here by taking the derivative of 6x, which will be 6. I'm putting that 6 in front. So f prime of x will be 6 times e to the 6x. So here dy is equal to f prime of x times dx. So that would mean dy will be equal to 6e to the 6x dx. And that's all there is to it for that problem. Okay. All right, problem number 24, A and B, is to determine whether the mean value theorem applies to the function f of x equal to e to the x on the given interval 0, natural log of 19. And if so, which is part B, find the point or points that are guaranteed to exist by the mean value theorem. Okay. So now we need to ask ourselves these 2 questions about the mean value theorem. And that's this. Is f of x equal to the function e to the x continuous on the interval 0, ln of 19, the closed interval 0, natural log of 19. And pretty much with e to the x, any x value that you assign to it within this interval, you're going to get a value for f of x. So that answer there is yes. And then the second question, is the function f of x equal to e to the x differentiable on this open interval 0, ln of 19? Well, let's take the derivative of f of x equal to e to the x. Well, that's easy. F prime of x is simply e to the x. And again, any x value that you assign within this open interval, you're going to get an f of x value for it. So again, this is a yes. So both requirements are met. The function is continuous on the closed interval, and it is differentiable on the open interval. So that means here the mean value theorem can be applied. So your answer choice there, that the mean value theorem applies because the function is continuous on the closed interval 0 ln of 19 and differentiable on the open interval 0 natural log of 19. And then we can answer part B. Find the point or the points that are guaranteed to exist by the mean value theorem. All right, so in this case here, let's first find out what f of A is and f of B is going to be. Since we have the closed interval 0 ln of 19, A is 0 and B is 19. And f of x is equal to e to the x, so that means that f of 0 is going to be, well, let's say f of A, and A is 0, so f of 0 will be e to the 0, that's going to be 1. Any non-zero number to a power of 0 is going to be 1. And then f of B, which is actually f of the natural log of 19, that's going to be e to the ln of 19. And this is one of those inverse properties of natural logs. Well, inverse properties of logarithms. E to the natural log of whatever is whatever. So e to the ln of 19 is 19. And that's for the fact that e and ln are inverses of each other. Okay. And since f prime of x is equal to e to the x, let's find out what f prime of c is going to be. That's just e to the c. Okay. And of course, the mean value theorem is just says this. F of B minus f of A divided by B minus A has to equal to f prime of C. Okay. So I would suggest you look over that mean value theorem. You'll find this here, okay? Because we're trying to find out the point that is guaranteed to exist in this case. So here, f of B was 19 minus f of A, which is 1. Oh, let's divide it by B minus A. B is the natural log of 19 minus A, which is 0. And that's equal to f prime of C was e to the c. Now let's simplify this. 19 minus 1 will be 18 minus ln of 19 minus 0, simply ln of 19, equaling to e to the power c. Now let's find out what c is in this case. Well, e and ln are inverses of each other, so I need to take the natural log on both sides of this equation. So ln of e to whatever is whatever, so ln of e to the c will be c. And I'm not going to do anything with this ln of 18 divided by ln of 19. So we're going to leave that as is. So if we were to answer that question, you'll just enter this as is. Okay, that would be the point where that is guaranteed to exist by the mean value theorem. That means that value there will exist within that interval. All right, so that's problem number 24. All right, number 25. This is where we use L'Hopital's rule to evaluate this limit. Okay, and that's when convenient and when applicable. is applicable because the fact is I'm going to get a 0 in the denominator. Here I got the limit as x approaches -1 of 6x to the 4th plus 4x cubed plus 5x plus 3 divided by x plus 1. And I'm letting x approach -1. So that means I'm going to have a 0 in the denominator. So to simplify this, I need to use L'Hopital's rule. So here I'm going to have the limit as x approaches -1. Take the derivative of the numerator and the derivative of the denominator. The derivative of 6x to the 4th will be 24x cubed plus the derivative of 4x cubed will be 12x squared. The derivative of 5x will be plus 5. The derivative of 3 is 0. Divided by the derivative of x will be 1. Now I can use direct substitution because I'm not going to get a 0 in the denominator here. So let's do this, 24, and then x is replaced with -1, that's cubed, plus 12 times 1, that's squared, plus 5. I'm substituting each x with -1, and this should be -1, not just 1. -1 cubed is -1 times 24 will be -24. -1 squared will be 1 times the 12 will be plus 12, plus 5. 24 plus -24 plus 12 will be -12. -12 plus 5 will be -7. So in this case here, the limit as x approaches -1 of 6x to the 4th plus 4x cubed plus 5x plus 3 divided by x plus 1 using L'Hopital's rule will be -7. Okay. Now number 26 are integrals. We're going to determine the indefinite integral, what it is. Here we got the integral of 2 over t squared minus 7t to the 5th dt. Now I'm going to write 2 over t squared using negative exponents here. So I'm going to have the integral of 2, pull the t out of the denominator, will be t to the -2 minus 7t to the 5th dt. Now I'm going to use a combination of the constant multiple rule and the sum and difference rule for integration. I'm going to pull the 2 in front. It'll be 2 times the integral of t to the -2 dt minus 7 times the integral. I'm pulling the 7 out in front. It'll be multiplied by the integral of t to the 5th dt. For each one of these, I'm going to apply the power rule. So if I bring the 2 down, add 1 to the exponent of -2 will be t to the -1. That'll be divided by -1. And then minus 7 times for t to the 5th. If I integrate that, I add 1 to the power, divide that by the new power, plus c. So again, each one of those, I'm applying the power rule. Now let's simplify this. Let's see. 2 divided by -1 would be -2. And I'm going to bring the t to the -1 in the denominator, make that t to the +1, or just t, minus 7 over 6 times t to the 6 plus c. So the integral of 2 over t squared minus 7t to the 5th dt will be -2 over t minus 7/6 t to the 6 plus c. All right, so that's problem number 26. All right, number 27 is another indefinite integral. This time there are trig functions involved in it. The integral of 2 secant tangent, the integral of 2 secant x tangent of x plus 5 secant square of x dx. Using the sum rule for this, it's going to be the integral, and I'm going to pull the 2 out in front. I'm going to use the constant multiple rule as well. So it'll be 2 times the integral of secant x tangent x dx plus, pull the 5 out in front of the integral of the secant square of x dx. So now I get 2 times the integral of secant x tangent x dx, if you recall from one of your integrals for trig functions, it's going to be just the secant of x plus the integral of secant square of x. Well, I need to bring that 5 down. The integral of secant square of x will just be tangent x, because the derivative of the tangent x is the secant square of x. And then, of course, since it's an indefinite integral, you must include that plus c. And the same holds true for problem number 26 that I did not too long ago. So that integral of 2 secant x tangent x plus 5 secant square x dx would be 2 secant x plus 5 tangent x plus c. And finally, number 28. We got the integral of 3 divided by 16s squared plus 16 ds. And we want to find its indefinite integral. And don't worry about the checking by differentiation. I'll let you do that on your own time. Okay, so in this case here, let's start by pulling the 3 out in front. This will be 1 over that denominator, 16s squared plus 16. There's a common factor there, which is 16. Let's take the 16 out, factor out the 16. Then 16s squared divided by 16 would just be s squared, plus 16 divided by itself would be 1. And I also can pull the 16 out as well. So it'll be 3 over 16 times the integral of, I need to include the ds there, the integral of 1 over s squared plus 1 ds. Now that integral of 1 over s squared plus 1, if I integrate that, that's going to give me, and you might want to check this out in the notes, the inverse tangent of s over a. So here, this is s, that's your a. S divided by 1, which would just be s, and then plus c. Okay, because this right here matches up with the inverse tangent. So my final answer there will be just 3/16 times the inverse tangent of s, and then plus c. Okay. All right, so that's the last problem in this review for the final exam. So that does conclude this video on the review for your final exam. There are 2 parts to this. This is just part 2. Part 1 you can check out as well. Feel free to contact me as always if you have any questions about any of the problems that are in this video. The review for your final exam is also on my math lab. So try to get as much practice as you need for the actual final exam on Wednesday, May 11th at 8 o'clock. I'll see you then.